right, so I think this section's somewhat easier than the other section. At least in my opinion. You might find it different, but let's get started. So we're doing section 3.5, solving equation and inequalities with absolute values. And so as long as a is greater than 0 for the algebraic expression, the absolute value of some algebraic expression, capital X, right, is equal to a, that means x equals negative a or positive a. If it's negative a, the absolute value, we'll deal with that later. Usually there is no solution, but we'll see that in a second. All right, so if I want to solve this equation, let me put that down. Nope, didn't mean to mute my mic. Move this over. So that means x minus 1, because I have an x here, is equal to either minus 4 or x minus 1 is equal to positive 4. So here, x minus 1 equals minus 4 gives me the solution of x equals minus 3. And here, this gives me x equals 5. And so those are my two solutions. So x equals minus 3 or 5. Here, if we want to solve this equation, first thing we want to do is get the radical, or not the radical, but in this case, the absolute value to one side or the other, like we did before. And so here we'll have x plus 3 equals 10, or absolute value of x plus 3 equals 10. Then we write x plus 3 is equal to minus 10, or x plus, oops, I wrote x twice, x plus 3 equals to positive 10. So it's either minus 10 or positive 10. Here, when we solve this through, we'll get x is equal to minus 13. Here we'll get x equal to 7. And those are your answers, right? X is equal to minus 13 or 7. All right, let's go ahead and solve this one. And so here, we're going to move everything to one side. So here we'll have, and in this case, I'm going to move this over. So I'm going to have 7 is equal to 6 plus the absolute value of x plus minus 1, just to keep that positive, move this over. So I'll have 1 equals the absolute value of x, 2x minus 1. That means, I guess I should give myself more room. It means 2x minus 1 is equal to negative 1, or 2x minus 1 is equal to positive 1. In this case, x is either equal to, in this case, it's 0. Sorry. Move it over, I get 0 on the side, 0 divided by 0, 0. And in this case, I get x is equal to 1. And so we have our answers of x of 0 and 1. So go ahead and try example 4 real quick. Give this a try. And let me know what you get. So give number 4 a try. And just put your answers into chat. No one got answers? Oh, okay, we got a couple answers. Yeah, so let's go through it. So here, this is already written as that, so it's minus 3x minus 4 equals to minus 13, or minus a third, or 1 over 3x is equal, or 1 over a third is oops, is equal to positive 13. And so once you do that, here, we'll move the 4 over. So it'll be minus a third x equals minus 9. So x equals minus 27. Here, we move the 4 over. Third x equals 17. 17 times 3 is 51. Okay, so those are your answers. All right. And so, I don't know, to me, in my opinion, stuff like this is like way easier than what we are just doing, right? I don't know, just maybe it's me. I agree. What was the last answer? The last answer is minus 27 and 51. Okay. All right, so the next one. So the inequalities get a little bit more interesting, but not that interesting, right? So here, if I'm still assuming my a is positive, I have an algebraic expression of x. So if the absolute value of x is less than a, where a is still positive, right? It's the same thing as x is between negative a and a. Because if it's less than a, so a good way of looking at this is if I have some, oh, we'll just see it in here, okay? And then if it's greater than a, that means the expression was less than minus a or greater than positive a. The same thing's for less than or equal to. And so you just kind of match it up here. So here we have x plus 8 is less than 9, right? So here we have x plus 8 is less than 9, but it's, and so we have this situation here. So we're going to put negative the 9 here and minus 9 here. And then we just solve the inequality. And here we're going to solve this inequality. All right, so when I solve this inequality, I'm going to add a minus 8 everywhere. So this will be minus 17 less than or equal to x less than or equal to 1. And we'll go ahead and write this in interval notation because I think that's how your homework wants it. So let's make sure we're doing what your homework will want. So it'll be open our parentheses here. 1, right? So x is this. And so let's look at some of the values here. I want it to be less than 9. So if x is 1, that means I'm at 9, but everything less than that. But notice if x was like negative 10, negative 10 plus 8 is minus 2, and minus 2 is definitely less than 9. And so here we encapsulate that. But if it was really negative, say it was like negative 20, that's just too big, right? Because then I'll have minus 12, right? Which is 9, which gives you positive 12. And so if I want to be less than this, that means what was inside was either it goes up to 9, but also I can go up to minus 9, right? Because it doesn't matter when you take the absolute value. And so you just want everything in that range when you solve for it. All right, so here we're going to do the other one. So here we have greater than or equal to some number, right? So here we have greater than or equal to. So that means 6 minus 4x is less than or equal to minus 8. Oh, I forgot the minus. Less than or equal to minus 8, right? So here I have the minus 8. So from here, right? And then or actually and in math, or and are the same. Oh, let me rephrase that. They're not the same. Let me see how I can say. In math means one, or means one or the other or both, and means definitely both. So when we're solving these equations, it should say, I should rewrite this. Actually, I should rewrite this as this or this, right? So that technically should be an or in the mathematical sense. I wouldn't worry too much about it. We'll solve it and I'll show you. Or we can have 6x minus 4, or 6 minus 4x be greater than or equal to 8. So it's either you switch. So if it's greater than, you flip the sign and make it negative, and then you solve for the greater than. If it's just less than, just put the positive I'll put the positive one in, put the negative on the other. Okay, so we solve this down. So we're going to get minus 4x is less than or equal to 14. And then since we're dividing by a negative, we flip the sign. So this is greater than or equal to 7/2 here. We move the 4 over, or the 6 over, so this is less than or equal to 2. Divide by that, so it'll be minus 1/2. And notice since we divide by negative, we flip it. And so here we're going to write this in interval notation. So this interval means x is from anywhere from negative infinity to 1/2. And we're including that half. Okay, so we include that. We'll make a little union here. I'm not sure if your book wants union signs or the comma. Either's fine. Just do whatever the book asks you to do. And then here we're going to go from 7/2, so we're actually going to achieve 7/2, so we're going to go all the way to positive infinity. Okay. So just make sure you know how to write inequalities as intervals. And we've done it throughout class, but still good to keep practicing until it becomes second nature. So my friend who came late, just remind me at the end, I'll mark you. Okay. In fact, I think I still have it up. You lucked out. I still have it up. Don't worry about it. I marked you. Okay. So that's how this one works. So let's look at this one. Yeah, so let's do this one. And so here's another one where it's greater than. So we're going to have 2x plus 1 divided by 3 is less than minus 5. Or 2x plus 1 divided by 3 is greater than 5. So here we just switch the signs once and do this. We solve. Here we're going to solve down. So we get, so we multiply 3 by both sides. That doesn't change too much. So this will be minus 15. And then we move over the 1. Which gives us minus 16 divided by x gives us minus 8. Here, we'll do the same thing. Multiply by the 3, so we get x plus 1 greater than 15. X plus 1, or 2x is greater than 14, so x is greater than 7. And so notice that this is everything from negative infinity to minus 8. So minus infinity to minus 8. Notice this is in parentheses since we're not equal to, instead of the bracket, because we were equal to. And then we're going to go from 7 onward to infinity. Okay. Where we at? Oh, here I forgot the minus sign. Thank you. Thank you. So number 6, it's everything less than minus 1/2, and so it should be minus 1/2, including the minus 1/2, right? So this one produces this one, and then everything less than that, so it's minus infinity to the minus 1/2. And then here, we're 7/2 or greater, right? X is greater than or equal to 7/2, and so it'll be 7/2 all the way to infinity. I forgot my comma here. Yep, thank you for pointing that out. Perfect. All right, so let's go ahead and let you guys try one. So go ahead and try to do this one. All right, so give this one a try on your own. Make sure to move the absolute value on one side, everything else on the other. So go ahead and move the 3 first. In fact, now that I mentioned, I'll just do it for you this time. So this will be less than or equal to 5. And yeah, so go ahead and finish it from there. And write your answers in interval notation in chat. Okay? This one's actually easily written in chat, so no fractions. So that should be a good hint. All right, any solutions? Let me do the next step real quick. So here the next step would have been is less than or equal to 5, less than or so that should have been your next step. Thank you. Did anyone get a solution? Are you still working on it? It's Tuesday, and after yesterday, I burned out your brains on math so much you don't care anymore. Oh, okay. Just making sure you guys are still crunching. I'm gonna go blow my nose as you guys work for another 2 seconds. Okay, we got a few answers, so let's go through it. So here we're just gonna add 2 everywhere, so it's gonna be minus 3. Square root of a half x, and then add 2 would be give me 7. And then we're going to multiply by 2 everywhere, so I get minus 6 less than or equal to x, which is less than or equal to 14. So here, we write this in interval notation. It's including, so I'll use the bracket. 2, comma, 214. Bracket. Yeah, so that's what you guys got. All right, so what happens when a is not greater than 0? So let's look at this. So let's solve this. Can we solve this? Well, the answer is no, right? There's no solution here. Why is there no solution? Why is there no solution? Why can nothing I put in here make this true? Anyone have an idea on chat? Clueless, honestly? Okay. So we have honest people. Notice that an absolute value can never produce a negative number. Hold on, did I write this wrong? Yeah. So here I have negative 5, right? The absolute value cannot be negative. This has to be, by definition, greater than or equal to 0, right? Because nothing I can do. So at no point am I going to have a number less than negative 5, right? And so the left side can't be negative. So the left side can't be negative. More or less than a negative number, right? It's strictly positive, so this can never happen. Oops, I have this one written backwards. Let me reverse the sign on this. What happens if we have this? Oh no, I did it right. I wanted to make sure one was one way, one's another. We're good. Okay. And so let's pretend we have a 0. Can this ever be less than 0? So in this case, what happens? And so here we have a 0. This can't be less than 0, but it can't equal 0, right? It can't equal 0. So here, if I have x equal, so here if I have 7 minus x less than or equal to 0, less than or equal to 0, because negative 0 is still 0, that means if I add 7 everywhere, technically you can solve this, right? You get x equal to 7 because you'll have 7 on one side, 7 on the other side, so it had to be 7, right? because you're getting a -7 everywhere, and then you divide by the negative sign, flip the signs, it's still 7. So we can have x equal to 7, right? And here, I want this to be strictly greater than 0. So if I want this strictly to be greater than 0, if I want this strictly greater than 0, that just means this wasn't 0, right? So here, x minus plus 5 was not equal to 0, because everything else will be greater than that, right? When it equals 0, so x does not equal minus 5/3. And so all the other numbers work. And so in this case, we from minus infinity to minus 5/3 union minus 5/3 all the way to infinity. Okay. And so you'll see a lot of different things. I might get kicked off. Okay. Yeah. Is it? Yeah, it's because the right side can't be negative. Why did it? If the left side can't be negative, why did it in example 8 work? Oh, so we're talking here. Notice example 8. I have this is less than this. I want to say that this, notice here, let me see if I can explain this as correctly as possible. I want this to be greater than or equal to 5, right? Or less than or equal to 5. And to solve that, I'm going to say it's either what's on the inside is greater than 5, is less than 5, or it's greater than -5. Because notice here, if I have negative, let's just test -4 real quick. If I plug -4 into this puppy, I get -2 minus 2, which is -4. The absolute value of -4 is +4, which is less than 5, right? If I plug in -6, I'll get -5 inside, which the absolute value gives me 5. If I plug in -8, so let's just test the negatives real quick. So -8 gives us on the inside here, this gives us 6. And or -6. -6 is the absolute value is greater than 5, so that didn't work. -6 here gives us exactly 5, right? Gives us -5. Because -6 here gives me -3 minus 2, which is -5, and that works. -4 gives me -4. -2 gives me -3, right? 0 gives me -2, which gives me -2 on the inside, but that ends up being, but when we translate it to the absolute value sign, let me just wander through this all the way. Let me write this down here so I have it. You don't need to write this on your notes, but let me just kind of explain what's going on here. So in x, so this will be my x, this will be, and this is the final value. So this is 6, that didn't work, right? This gives us -5, which gives us 5 when we take the absolute value. This gives us -4, which gave us 4 as an absolute value. This gives us -2 gives us -3. So it gives me 3. 0 gives me -2, which gives me 2 as an absolute value. 2 gives me 0, which gives me 0 as an absolute. Oh no, 2 gives me, I'm sorry, 2 gives me 1, or -1, which gives me 1. 4 half times 4 is 2. 2 minus 2 is 0. It gives me 0 as my absolute value. Let's just keep going. And so just trust me that 6, 8, 10, and 12 give me 1, 2, 3, and 4 respectively, which gives me the absolute value 1, 2, 3, and 4. Okay. And so notice here we can do this little range right here. So I want the absolute value to be less than 5. Well, here I can go all the way to -5, and then my absolute value is still, or less or equal to 5. So if I go to my -5, whatever value makes a -5, I still get a 5 out. And then as I walk towards the value that gives me 5, I still get values which are less than 5. So that's how it works on this case. Okay, so that's why in 8 we're allowed to have, we can split it this way. Notice here we're changing what a, we're having a not equal to. Notice less than or equal to, either way this fails, right? And for 0, we can have like a single solution, or we may have to throw away the solution. So it gets interesting when we add the 0. So the rules aren't clear for the zeros, but for most of the time, it's for most of the other rules, you just go ahead and run off of this. Okay. All right. That's the notes for the day, guys.